Hello and welcome to the Top Chemistry. My name is Muhammad Ghulam Kibriya. I have passed from Chittagong University at the Department of Chemistry. I have passed from BSc Honors MSc from Chittagong University. I am going to be your teacher here during this course, and what you are going to find is that during the entire class where we talk about chemistry, we are going to take every single topic from step by step. My dear students, we are going to build your knowledge in small little incremental measurable steps. So every step along to the way you are going to be able to follow everything that's going on before you know it. Today our topics are: number one, relationship between moving particle and wave. Number two topics, calculation of wave number of electron revolving in an orbit outside the nucleus of an atom. My dear students, let's start. We are starting our topics. Number one topics, you know, relationship between moving particle and wave. Let's start. Relationship between moving particle and wave. Relationship between moving particle and wave. We know what is moving particle and we know what is wave. Relationship between moving particle and wave. Dear students, we know what is moving particle and what is wave. We have idea about moving particle and wave. Moving particle, which can change its position in course of time. Scientist Bohr, we know scientist Bohr atom model electron is treated only as a moving particle. We know according to Planck's theory, according to Planck's theory, according to Planck's theory, the energy of a photon, the energy of a photon, the energy of a photon E equal to H nu. Number one, we know the formula. We know the formula of Planck's theory. We know the formula, the Planck's theory. What is Planck's theory? E equal to H nu. E equal to H nu. We know what is E equal to energy. H equal to Planck's constant, nu equal to frequency. Nu equal to frequency. Number one equation. We can on the other hand, according to Einstein's theory, according to Einstein theory, according to Einstein theory of equivalence of mass and energy, of equivalence of equivalence of mass and energy. And energy of mass and energy E equal to mc square. Equation number 2. Equation number 2. We can compare equation number 1 and equation number 2. Again we can tell that E equal to h nu. Again we know about according to scientist Einstein, E equal to h mc square. Equal to mc square, where m equal to mass of moving particle, where m equal to mass of moving particle. Here m equal to mass of moving particle, c equal to velocity of light, c equal to velocity of light, and also E equal to equivalent energy. E equal to equivalent energy. Equal to equivalent energy. Combining, we can combine, my dear students, we can combine equation number 1 and equation 2, and we can calculate easily. We can calculate this equation easily. Combining the these two equation, combining, write down please. Combining this equation we get, combining equation number 1 and 2, we get what we can write down, mc square equal to h nu. mc square equal to, আমরা এখানে we can compare equation number 1 and equation 2. We have seen that E equal to h nu equal to mc square, so we can write down h nu equal to mc square, we can write down, or mc square equal to h nu. H nu equal to h into c by lambda, equal to h c by lambda, equal to h c by lambda, we can write down, or we can write down mc square equal to hc by lambda. We can divide, we have seen that in left side c, also in right side also c. We can dividing on both sides by c. We can dividing on both sides by c. That means why can we write down? We can write down mc equal to h by lambda, mc equal to h by lambda. We can write down mc equal to h by lambda. Since the mass of a photon, the mass of a photon equal to m, the mass of photon equal to m, velocity of photon equal to c, velocity of photon equal to c, so mc equal to momentum of photon, so mc equal to momentum of a photon. My dear students, we can write down lambda equal to or cross multiplying mc into lambda equal to h by mc. We can write down lambda equal to h by mc. We can write down, we know what is lambda, what is H, what is M, and what is C, we know. According to Broglie equation, according to Broglie said, scientist Broglie said web is associated also. Web is associated also with a moving particle, also with a moving particle. The wavelength of such the wavelength of such matter wave follows similar equation, so we can write down, momentum equal to mb for electron, momentum equal to mb, we know momentum equal to mb. Equation of the wave become electron wave becomes, so electron wave becomes lambda equal to h by mb. That means we can tell that we can write down mb instead of mc. We can write down, dear students, we can write down mb instead of mc. So this equation is known as the Broglie equation. This equation is known as the Broglie equation. My dear student, first one we have completed. Next one we are studying. Write down, please. Write down, everybody. Second question is that calculation of wave number of electron moving in an orbit outside the nucleus of an atom. Calculation of wave number of electron. Calculation the wave number of electron. The wave number of an electron revolving in an orbit outside the nucleus of an atom. Outside the nucleus of an atom. Dear students, according to Broglie, we know an equation which has we have derivated. According to Broglie, we know lambda equal to h by mb. Lambda equal to h by mb. Equation number one. We know what is lambda. We know what is Planck h. We know what is m. We know what is b. We know lambda equal to wavelength, h equal to Planck's constant, B equal to mass of electron or mass of particle, B equal to velocity of electron or velocity of a particle. According to Bohr model, according to scientist Bohr model, we get MBR equal to n into h by twice pi. Dear students, we know angular momentum MBR. We know angular momentum MB equal to n into h by 2 pi. We know what is n. N equal to 1, 2, 3 and so and so. That means integer number. Purno integer equal to integer number. That means the value of n will not fraction. That means the value of n will not fraction. N is an integer number. The value will not in fractional number. Twice pi or MBR into twice pi equal to NH or MB into twice pi R equal to NH or twice pi R equal to NH divided by MB. My dear students, 2 pi R. We know 2 pi R is a circumference of an orbit. We know 2 pi R. We know about 2 pi R. We should know 2 pi R. What is 2 pi R? We should know. We can write down 2 pi R equal to n into h by twice pi n is by MB, or 2 pi R equal to or 2 pi R equal to or 2 pi R equal to n is by n lambda n lambda. That means we can write down this value n into lambda from equation number 1. From equation number 1. Dear student, we should know we are putting this value h lambda h by MB equal to we can write down lambda. We are putting h by twice pi equal to lambda or lambda equal to h by MB. We have write down here. So 2 pi R. We know mathematically what is 2 pi R. 2 pi R means 2 pi R is circumference of an orbit or circumference of a circle of a circle. Here 2 pi R is the circumference of orbit. Here 2 pi R. Here 2 pi R is the circumference of an orbit. Dear student, we should know 2 pi R is the circumference of an orbit. That means the orbit number. That means the orbit number. That means the orbit number determines the number of determine the number of complete oscillation or wave. The number of complete oscillation or wave. My dear student, we know 2 pi R. We know what is 2 pi r. This is 2 pi r. This is 2 pi r. Complete oscillation. Complete oscillation. It is called complete oscillation. Complete oscillation or wave. My dear student, today we have discussed two questions from qualitative chemistry. From qualitative chemistry HSC first paper chapter 2. Please everybody should prepare more and more for your final exam. Thanks everybody, thanks everyone. Assalamu alaikum.